Hey, this is Carrie, and in this video we're going to be making an integer multiplication game. So hopefully I've demoed this game in person, but at the end we should all have a game that looks like this and keeps track of our scores. And then when we get one incorrect, turns the screen red, and we lose our streak. Now you guys can't hear it, but as you're playing the game, it does play some sounds, so that's one of the fun parts about it. And we'll show you how to do that in this video as well, even though you can't hear the sounds through the headphones. So next up, what we're going to be doing is let's take a look at our starter file. So together we've all kind of gone to this stage where we've got a very crazily different looking, kind of very plain HTML file. So let's immediately start by adding some style to the document. So the way that you add style is we need to add CSS code. And so I need a way of marking in my HTML that I'm going to be coding in CSS in that section of it. So the way that we do that is we go into the head of our document, and we start to create a style tag, so STY, and then once it auto-completes, press tab, and you've got your style tags all set up. What this means is that all of the code inside of these two opening and closing brackets is going to be interpreted as CSS code. So CSS code in general for me takes a long time to get right, and it can be a little bit guess and checky and not very good for a video. So what I did was I sent you all of the CSS code for the entire document. So you can just highlight all the CSS from the toolbox, copy it, and then paste it into style. So you'll notice that regular paste actually messes up the formatting. So instead, I'm going to be using Command-Shift-V for pretty paste, which will keep the formatting. And it's a little bit overwhelming to see all of that CSS inserted in at once. But what that CSS does is it turns this file from this HTML file with no style to, let me give a save here, and then a refresh in the browser, this much more stylish looking file. So you'll notice that the contents on the page are exactly the same, but that they've all been styled differently. So at this point, if we haven't done it already, it would be a good time to pause the video, or pause kind of whatever we're doing, and start to mess around with some of these values. It's pretty easy to pick things out, like changing the colors or changing the backgrounds and using different color keywords and messing around with the font sizes and getting this configured to a place that you like. But I kind of like the way it looks right now, so I'm going to leave it as it is. So the part that I really want to focus in on with this video is kind of the most complicated part of the web app, which is actually creating the functionality. So to create the functionality, we're going to be using JavaScript so that the user can interact with the web page. So JavaScript works similar to style. In order to insert JavaScript into our HTML document, we're going to be adding not style tags, but this time in the body of the document, right at the very end, before the closing body tag, we're going to be adding script tags. So we type SCR for script tab, and now we've got our JavaScript environment all set up. So we're going to be coding in JavaScript here, and the first thing that we need to do is we're going to be interacting with all of these HTML elements on the page. So to do that, let's start by selecting the elements that we're going to interact with. So 2 slashes in JavaScript is a comment. This means it's a line of code that's not read by the computer, but might make it easier for us as learners or us as programmers to understand. So select the elements on the page that we are going to interact with. So to do that, you can go to your JavaScript toolbox, and right at the top of that, this is such a fundamental idea, selecting elements. We've got 2 different ways to select them. We can select elements with their element type or with their ID, and there's only a small difference. So I'm just going to copy this tool and paste it in a couple of times. So now I'm ready to start selecting the elements on the page. So the first element on the page that's going to change is this 0. So looking at the HTML code, in particular, that 0 is this element right here that I highlighted. So to select that, I'm going to say let the streak span. And the reason why I'm choosing that variable name is it keeps track of the streak, which is how many in a row, and the element type is a span. It also matches this unique identifier, this ID, to refer to that element. So to select streak span, I'm going to say select the element with ID, so hashtag streak span. Copy and paste. Now, very similar to this, we're going to have one for this element, high score span. So high score span and hashtag high score span, because that's the ID of this element. And in JavaScript, capitalization matters, so make sure that you're consistent with capitalization. Next up, the next thing we might need to select is, it looks like when we play the game, the background of the body can change from red to green to blue. So I'm going to select the entire web page. Now that web page is all inside of these body tags. So I'm going to select the body. So let body equal. And this time I'm not going to be using a hashtag because I'm not going to use an ID to select it. You can also say select all the elements of type body. So there's only one, so I'm just going to select the body. Next up, we've got some more stuff to select. We're going to need to change the problem. So I'm going to call this problem span, which refers to just this chunk that's in the problem. So problem span, and I'll use the ID hashtag problem span that we wrote here to select that. Next up, for this variable name, we're going to select the answer input, which is this input field. And we'll use the ID answer input for that. And then next up, why don't you think about how would you select this button? So you can pause the video there and try to do it yourself. I have to do it anyway, so I'm going to say let submit be the thing with ID hashtag submit. So I'll give that all a save. If we refresh the page, it looks like nothing has changed. However, if we bring up our JavaScript console, which is a useful tool from Vue Developer Tools JavaScript Console, we can now see actually that if we type in submit down here, it now actually recognizes that submit is this button. Or if we type in instead down here in the console answer input, it now recognizes that answer input is this field right here. So now the JavaScript code has access to all of this stuff on the page. All right, this tool is actually really useful for debugging, so I'm going to leave it open as we code this. Now we're going to set up some calibration variables, like how far we kind of want to go with multiplication. We could do from 5 to -5. I'm going to do from 12 to -12. So calibration variables. So we've sidestepped this a little bit, but whenever you create a new variable in JavaScript, you have to allocate that space in the computer's memory by declaring that variable. So let's say let max value equal 12. So inside of the code word max value, we're storing the number 12. And then the minimum value that I want for my multiplication problems would be, let's say, -12. Next up, we need to keep track of the streak, the high score, and a couple of other things. So let's initialize some variables. So I'm going to start the streak off at 0. So let streak counter equal 0. I'm going to let the high score counter also equal 0. And I'm going to let factor 1 and let factor 2. And these are pretty weird looking lines of code. We're just saying that later on we're going to be storing a value in factor 1 and a value in factor 2. Those are going to be these numbers here and here. And so I haven't put a value there yet because it's going to be a little bit of a process to come up with those. But by defining these variables here, all the functions that we create will have access to them. If you're an experienced programmer, we're defining them kind of in the global scope so that all the local scopes have access to them. All right, so jumping down into the rest of the code, when we're generating our problem, we're going to be creating random problems that our students can play forever. So to do that, we need to come up with a random number here and a random number here. So to do that, in our toolbox, we actually create a new tool. This function generates a random integer between min and max. So to use this tool, first we have to copy this tool over, Command-Shift-V into our JavaScript, and now all of our JavaScript code has access to this tool. So if we save our code and we refresh it in our window, now we can, in the console, use this new function. So we could type generate random from -5 to 6. And each time, and I'm just pressing up to get the same code, the up arrow, each time it should generate a different random number. 4s and 2s are popular. But we're not going to be using the console to do this really. We're going to be using this function later on in our script, and everything we type after this will have access to this function. So now we have to think about kind of what we're doing here overall. And I like to break this problem up into a couple of different pieces. So we're going to have to create a problem, we're going to have to check if it's correct, we're going to have to do something if it's correct, and we're going to have to do something if it's incorrect. So I'm just going to lay out all the pieces at once. We're going to run a procedure every time we're correct. So let's give that function a name. And actually, you can get into the toolbox and create a new function of your own. So this looks a lot like this function that we created, but this is just the general structure. So the function that we're going to create now is process correct. And that function is going to have no variables, so we leave the parentheses empty. We're also going to have a process incorrect, so I'm going to copy and paste this and change that to process incorrect, which will be what happens, a list of commands that happen when they get it incorrect. We'll also have a function called create problem, and I'm just copying and pasting all of this. And then finally, we're going to have, oh, not finally, maybe, I'm not sure. We're going to have a function that happens called check answers. So we have all the pieces, and now we just need to actually figure out what we want to do when all these things happen. So maybe for now, all we need to do is when they're correct, we could just say log to this console that they got it correct. So console.log correct. For incorrect, maybe we could just say for now console.log incorrect. And then we could focus at first on creating a problem. So when you think about making a math problem like this, it's pretty straightforward. You make up a number here, you make up a number here, and you kind of can do those things randomly. So to do those in JavaScript, the number here, we're going to call that factor1. So now we never gave meaning to factor1 or value to factor1 before. Let's create a value for it now. So, oops, that's the wrong one. This is not when we check an answer. This is when we create a problem, so it's up here. So when we create a problem, let's let factor1 equal, and then we run this generate random function that we created. So generate random, and then the minimum value is going to be minimum value, which is -12, and the maximum value is going to be 12, which we can use with the code word maximum value. Every line of JavaScript ends with a semicolon, so you've seen me do that throughout the code. Let's also do the same thing for factor2. And at this point, we need to actually put those into the problem text. So problem text is equal to, and this is the first time we're creating problem text, so let's say let problem text equal. And then the way that we structure this code is we're going to start with a $sign. So start with a $sign, then add to that whatever number we came up with for factor1. And that's not going to be in quotes because we're not seeing it as the word factor1, we're seeing it as the numerical value factor1, which is like what's stored in the code word factor1. So then next up, we're going to have to add to that slash times. And so you put 2 slashes because slash has a special meaning, and 2 slashes will cancel out the special meaning of the slash and just make it a slash. Then we do plus whatever factor2 was, which goes here, and then we do plus in quotes an equal sign, and then a $sign. And these 2 signs, you're going to see the purpose for them later. Basically, they're a way of demarcating that everything in here should be read as a math formula. So everything in here should be read as a math formula, so we're starting it with $and $. So save it. Then next up, we're going to let's display the problem. So to display the problem, we want to say, take this problem text that we just created and put it inside of this element. So to do that, you go to your toolbox, and when you change what's inside of an element, you're going to change the inner HTML of that element to a new value. So copy this and paste it over. So the element whose inner HTML we're changing is this part right here. And we actually selected that earlier. That was problem span. So we're going to say problem span, and then make the inner HTML of that equal to this problem text that we just created. So let's give it a save and a refresh on our page. And because we've created this function createProblem, we can go into the console and we can run this function now. So let's create a problem. And you'll notice that our problem changes. Let's create another problem. Let's create another problem. Let's create another problem. And so I'm pressing up and then enter to run this code, up and enter. And I'm noticing that just for my visualization, I would like to see a space here and a space here. So I'm going to add that to problem text. So factor1 plus space / to put a space here, and then factor2, and then before the or after the times a space, and before the equal sign a space. So refreshing it and creating some problems. Yeah, that looks a little better to me. Okay. Now let's finally get to actually converting this to mathematical looking text. So in order to convert this to mathematical looking text, we need to install an expansion pack to JavaScript called MathJax. So the way that we're going to install this expansion pack is, in order for our script code to have access to it, we need to go into our toolbox, and then using the MathJax expansion pack, we need to copy and paste the following two script tags. So this script tag and this script tag, we're going to copy and paste them. And we have to put those before our script tags because we have to install those expansion packs before we actually use them in our JavaScript. So I'm going to do Command-Shift-V here, and that pasted in these two different script code lines. The first one installs the expansion pack from a website, and then the second one configures it. So let's give it a save and a refresh. So now what you see is it automatically converts it to this beautiful looking JavaScript formula, or not JavaScript, math formula. But if we go down here and we type in createProblem in the console and we press enter, it doesn't automatically rerun the configuration. So to make it rerun the configuration, as the last step in creating a problem, we go to our toolbox and it says to rerun the MathJax parsing of the page. So let's copy this and paste this over here. And what this does is it reparses the web page. So after we create the new problem, add the problem to the page, and then we need to reparse it so that it rereads this as a math formula. So now we save it, we refresh it, and every time we create a problem, oops, problem is not defined. Let's see, I'm going to change that in the toolbox so that you guys won't have the same error. It looks like it's problem text that we need to reparse. So sorry about that, I'll change that. So now when we create a new problem, it automatically reparses the problem text. So that's pretty powerful. And you can put crazy complicated looking formulas in here. And that's actually what I did with the factoring one. And maybe this is a nice tool for math teachers to know how to use. All right, so now let's see what needs to happen. We need to actually be able to check our answers. But before we get to checking our answers, when do we need to check our answers? We need to check our answers whenever we click this button. So the way that we listen for clicks on this button is we use a tool called an event listener. So we're going to go into the toolbox, and let's find our event listener. So what an event, or here we go, here's our event listener. And it says event listeners are used to run a procedure after an event happens. So let's copy this, and then let's put this event listener down here. And you want to use, not what I did, Command-V, you want to do Command-Shift-V so that it maintains that nice formatting. Now the way an event listener works is you have to specify what element is listening for the event. Well, we're going to be clicking on this button. So going up, it looks like the submit button is what's going to be listening for that event. So we'll say submit should have an event listener. The type of event that it's listening for is going to be a click event, and that's whenever it's clicked with the mouse. There are a couple of other events like mousing over it or dragging it or typing on your keyboard that you might use another time. But in this case, it's a click event because we're clicking it with the mouse. And now down here, whenever we click that, we have to think, what procedure do we want to run? And it's pretty straightforward. We want to run this procedure, check answers. So we just put check answers as a procedure. So now to check answers, I guess it's really check answer. I'm writing this after redoing this and turning it from the factor one where we had two different answers, so I'm going to keep calling it check answers. Now we actually have to define what this check answers procedure is. So to make sure that our event listener is working, let's say that the first thing we should do is we should log into the console. Answer is being checked. So let's give it a save and a refresh. So now when we click the button, this event should trigger, and we should run check answers, which means that answer is being checked should appear in our console. Whoa, awesome, it is being checked. Now below that, what we really want to do is to check the answer, we have to get the answer first. So let's get the value that they put here. So let's let answer, a new variable, be equal to, what did we call this white box here? We called it the answer input. So go into the answer input and take whatever value the user put in. And this is a tool that's in our toolbox. It says here to read or assign values from input elements. We use this .value tool. So here we go, let answer equal answer input .value. So now we've got the answer. Let's make sure that we're getting the answer correct. So let's console.log whatever's currently stored in answer. So if we put 45 here, submit. Oop, I have to refresh the page. 45 here, submit. Answer's being checked, and it is reading the answer correctly as 45. So the next part of checking the answer is to actually check if they got the right answer. So if, oh, and actually let me just use the toolbox here. Whenever you want to create a branch in your program where one thing happens if they get it right, another thing happens if they get it wrong, you use conditional statements. So I'm going to copy and paste this giant chunk. Here there are only two options though. Either they get it right or they get it wrong. So I'm going to delete this else if. So now the condition that would mean that their answer is correct is, well, let's think about that. What would make this answer correct? If their answer is equal to, what do we call, or how do we check these? These are, factor 1 and factor 2. If their answer is equal to factor 1 times factor 2. And JavaScript uses a symbol asterisk for multiplication. There is a mistake in this line of code. So as mathematicians, we use the equal sign pretty interchangeably for a couple different purposes. We use equal sign to say let x equal 7, and then we use it to check is x equal to 7. In programming, to check if things are equal, you put or in JavaScript, you use 3 equal signs to check if these are equal. Or 2 equal signs to check if they're equal. And there's a slight difference between those. I'm going to stick with 2 equal signs in this video. So if answer is equal to this times this, then they got it right. So then we want to run process correct. Process correct. If this is not true, then that means that their answer was not equal to factor 1 times factor 2. So down here, we'll just process incorrect. And now I think we've got pretty much everything set up. So let's refresh it, and let's get it correct. So -15. Submit. Answer is being checked. -15. Oh, and they said it was incorrect. I wonder why they said it was incorrect. Let's try that one more time. I know why. We actually haven't made the initial problem yet. We haven't created a problem. So before we can check our check answers function, in addition to doing this, whenever they load the page, we want to create a first problem. So this was a temporary placeholder problem that hasn't really been generated by the JavaScript. So when they load the page, we want to create a problem to go here. That sounds kind of like an event. So let's create another event listener. And this event is not going to be a click event. So let's find our event listener code. This event is going to be an event that triggers when the page loads. So for this event, what we want to say is when the page loads, create a problem. So that would be the entire document is going to listen for a load event, which is DOM, document object model, DOM, content loaded. And when it loads that, we want to create a problem. So when the page is loaded, create a problem. Save it, refresh it, and now our problem is 1 times 2, and now we should be able to check it. So you type 2, submit, the answer is being checked, It was 2, and it's correct. If we get it wrong, -4, submit. The answer is being checked, -4, and that's incorrect. So our code is running pretty close to how we want it to. The only thing we need to add now is being correct and being incorrect should do more than just say console.log correct or console.log incorrect. So what they really should do is a couple of things. If we go back to the code over here, what happened was when we got it correct, the screen changed colors, our streak went up by 1, and it also plays a little song. So let's console.log correct. What we should do is we should say, where are we keeping track of this streak? Well, that streak is starting off at 0, and each time we get one right, we want to say, replace in that streak counter, make it equal to whatever the streak counter was before, in this case 0, add 1 to it, because now our streak is 1 better. I'm going to put that semicolon that I often forget. Next up, we want to say, once we update this 0, we want to put that new value into this inner HTML. So we'll go and we'll grab from the MFA toolbox this tool to change the inner HTML. So we're going to say let streak span, that's the name of this location that we're trying to store something at. Let streak span's inner HTML be the streak counter. So in this location, we're going to store whatever the count is currently up to. We're also going to say take the body and restyle the background so that the background is green. Now, if we're incorrect, we're going to do some really, actually we're not done with if it's correct yet. There's a couple of new things that we have to add. One is the very last thing we should do after getting one correct is to create a new problem. So we mark it correct, we add 1 to the streak counter, we update what's shown on the page, and then we make the background green, and we create a new problem. So let's give it a save, and let's see if that works. So -9 times 3, -27. Cool, so it's green, streak went up by 1, and they've got a new problem, but we need to clear out this answer box right here. So to clear out that answer box, the name of the answer box was answer input. So we need to say answer input. Let's make the value of that equal to an empty string with nothing in it. So now the value will have nothing in it. So next up, let's check that. So -2 times 9 is -18, submit, and new problem, blank box. -9, our streak goes up, awesome. So now processing incorrect is going to be really similar. What we need for incorrect is we need to do make the background red. So take the body element, make the style background equal to red. Next up, what we need to do is we need to, now their streak has ended, so we need to set their streak counter to 0. And then we need to make what's inside of the streak span equal to whatever the streak is, which happens to be 0. And I actually don't want to create a new problem here. I like the idea that if they get one problem wrong, that problem sticks around. So -9 times 1, if they put -100, I like that it kind of causes an error there, and then they have to figure out that it's -9 in order to start their next streak. Okay, and things are starting to look pretty complete. I noticed that one thing that's messed up is the high score. So we can code in the high score, which is if they get something right, so in process correct, before we change the answer value to nothing, we could say if, and I'm going to go to the toolbox and grab my if tool, if, and then for the condition, if the streak counter is greater than the high score counter, so if the number, high score counter, let me rewrite that everywhere that I have it, high score counter, sorry about that. If the streak counter is bigger than the high score counter, then our high score counter should change in value to whatever the street counter is. And in our high score span, we should make the inner HTML of that equal to the new high score, which is the high score counter. So now as we play the game, -40, submit, the high score will continue to go up every time we get one correct. And if we get one wrong, streak goes back to 0, but high score is still the old value. So now if we try to set it over again, the streak will go up, and once we surpass the high score, it should replace it. I think the last thing I wanted to do with this is to add some audio to it so that it feels a little bit more like a game instead of just a lot of problems. So to make it feel more like a game, the sounds are actually really easy to add. So the first thing we have to do is we have to add the sounds to the content of the page. So we're going to switch back over to HTML, and before the first script tag, we're going to add an audio element. And audio elements get two attributes. They get a source, and they get an ID. And the source is the name of the file. So in my case, the name of the file is write.wave, and the ID is going to be write. I'm going to do the same thing for the wrong one, and these are going to be sounds from Mario. You won't be able to hear them through the headphones, but it should feel really satisfying to hear them through your own speakers as you get the problems right or wrong. So now that we've got these two elements on the page, we want our JavaScript to be able to interact with them. So we need to select them. So I'm going to add two more selecting lines here. I'll copy this, and I'm going to say let write equal the item on the page with ID of write. Let wrong equal the item on the page with ID of wrong. That's going to be this audio element. And then to play those sounds, when we get something correct, right after we turn the background green, let's go into our toolbox and grab audio stuff. So to play a sound, you copy and paste these two lines of code, and then you change the word sound to the word that you want to play, or the sound that you want to play. When we get it correct, I want to play the write sound. So this will be write.currentTime, and this will be write.play. And then very similarly, when they get something incorrect, after turning the background red, we're going to make the background, or we're going to make wrong play. So wrong's current time is 0, and then wrong.play. And now, as they get problems correct or incorrect, it should play the sounds. And this is useful as a teacher for when you're checking whether students are making progress, because you should be able to audibly hear as your students are getting things correct, and they should be able to audibly hear as they're getting things correct and feel proud of those answers. And that will kind of give you a sense for how things are going as you kind of check in around the room. All right, I think that this is enough for this video where we've actually created the entire web page. The next thing that we're going to do maybe is how to put this web page online. So feel free to save and refresh and test your web page out to make sure that it's working as you expected.